So today we'll discuss all the questions based on reflection by mirrors. So we have already covered these ray diagrams. There are 6 cases in concave mirror, as we all know. So we can place object at 6 different positions in front of the mirror. And for those 6 different positions, we get images, okay, at different places. So you can see that in this table, we have, real image every time. There is just one case where we get virtual and erect image, and that is the case when the object is placed between pole and focus. This is the only case where we get virtual image. Clear? Okay. All these ray diagrams we have done already. I hope इसमें कोई doubt नहीं है किसी को भी, सबको clear है. Because ये basic concept है, ये आना चाहिए, तभी आपको negative, positive, clarity, sign convention की होगी, otherwise नहीं होगी. ठीक है? Okay. We had also covered ray diagrams by convex mirror. And there we had done just 2 cases. Okay, एक हमने क्या किया था at infinity और एक हमने किया था in front of the mirror, between infinity and pole of the mirror. And in both the cases we get virtual and erect image. So in convex mirror we never get real and inverted image. ठीक है, we always get virtual and erect image. And image is always diminished. It is smaller than the object. See, in concave mirror, where the case where we get virtual image, look at this case. The case where we get virtual image is the case where the image formed is highly enlarged. While in case of convex mirror, the image formed is virtual, but it is smaller in size. In plane mirror, we get the image of same size. So virtual images may we have, different sizes of image in different mirrors. But आपका जो real and inverted image है, you always get your real and inverted image in concave mirror, not in convex mirror, neither in convex nor in plane mirror. Now we have questions based on this. You are going to answer these questions. Please keep yourself unmuted. Okay, name the type of mirrors used in automobiles.
Convex mirror.
Yes, it's convex mirror. Okay, question number 2. What is the position of the object when we get a diminished image with a concave mirror?
Infinity.
There we get, if the object is placed at infinity, then the image formed is point-sized. Diminished is smaller in size. You can see the image beyond C. Infinity is also correct. Smaller image is formed. But if you place the object beyond C, then also you get image which is smaller in size and it is formed between focus and center of curvature. Okay, what term is used to define the geometric center of spherical mirrors? Pole. Next question, what type of images are formed by concave mirrors?
Real images. Real and virtual.
Real and virtual both. Okay, next question. What type of mirrors are used in headlights of vehicles?
Convex mirror.
In headlights, we use concave mirrors. Okay, in headlights, we use concave mirrors. Next question. Why does the image appear thin or bulging in spherical mirrors? In spherical mirrors, why do we get the images which are thinner or bulging?
Ma'am, curvature के कारण होगा, because वो spherical होती तो वो curvature.
Yes, because they are curved and light rays either converge or diverge, right, upon reflection. Next question. What type of mirrors are used by dentists or ENT specialists?
Concave mirror.
Concave mirrors. और किसी को आंसर नहीं आता? You all have to respond, okay? What type of mirrors are used in salons?
Plane mirror.
Where will the image of stars or moon be formed for a concave mirror?
Focus.
Focus.
Pause at focus because they are at infinity. Name the mirror that can give erect and enlarged image of the object. Name the mirror that can give erect and enlarged image of the object.
Convex mirror.
See, convex may we always get smaller image.
Concave.
Yeah. Now this time we want the image to be enlarged, larger image, na? So concave mirror is the correct answer. No matter how far you stand from the mirror, the image appears erect. The mirror is likely to be.
Plane mirror होना चाहिए.
And what about convex? We can have both. Both concave, in both convex and plane mirror, we can have, we always get virtual image. An object is moved with speed v towards the plane mirror. What is the speed of the image?
हम v होनी चाहिए शायद से.
Fine. See, if the object is moving towards the mirror, then the relative distance, the relative separation between the object and image changes by? See, initially, if you assume that object is placed at a distance of 5 centimeter, in that case, what is the distance between object and image? It's 10 centimeter, right? Because we know that image is formed as far behind the mirror as the object is in front of it. So if the object is placed at a distance of 5 centimeter, then its image will be formed at a distance of 5 centimeter behind the mirror. What if we decrease the distance to 4 centimeter? Then now the distance between object and image will be 8. So separation decreases by 2 centimeter if we decrease the distance by 1 centimeter.
तो 2v होगा फिर.
An object is placed at a distance of 2f from a concave mirror focal length f. The image distance is?
2f होना चाहिए.
Yes, it's 2f. At C, we get the image at C.
c only और same size की होती है.
Yes, same size, real and inverted. What condition is necessary for virtual image in concave mirrors?
Object should be placed between focus and pole.
Yes. Name the mirror that can give erect and diminished image of the object.
And convex.
Yes, it's convex mirror. In the mirror which is also known as converging.
Concave mirror.
Name the mirror which has virtual focus.
Convex mirror.
Name the mirror which is also known as diverging mirror.
Convex mirror.
Name the mirror which has real focus.
Concave mirror.
So these are the formulas we are going to use. Okay, please write the formulas first and then we'll move to the questions. After this, we have sign convention and then we'll move to the questions. Okay. Done. Now we have sign convention. So height of the object, we always take positive. And height of the image, we can take positive or negative. That depends upon the nature of the image that is formed. If the image is real, it is upside down, then we take height as negative. And if the image is virtual, then height of the image is taken as positive, right? U is always negative, right? And how do we measure distance? We always measure distance from the pole. So pole to C, pole to center of curvature, pole to focus, pole to object, and pole to image. So if we are measuring the distance in the direction of incident ray, then the distances are taken as positive. While if we are measuring the distance against the direction of incident ray, then we take distance as negative. For example, if we have a real image, or if we say that object is placed at this position, this is the position of the image. So we'll measure the distance from, look at the cursor, from pole to this object. And this is the direction of incident light. Now here we are moving against the direction of incident light. Pole to, we are moving towards object, right? So we'll take the distance as negative. U is always negative. In case of concave mirror, focal length is negative, while in case of convex mirror, focal length is taken as positive because it is behind the mirror. Sorry, it is on the other side. Okay, ये हमने साइन कन्वेंशन की हुई है और ठीक है. तो मैग्निफिकेशन क्या होता है? It gives a relative extent to which the image of an object is magnified with respect to the object size. And mathematically, we write the magnification as ratio of the size of the image to the size of object. It is denoted by the letter small m. ठीक है, तो ये आपका फॉर्मूला हो गया h dash by h और minus v by u. We take m as negative when the image formed is real. See, अगर real image है तो आपका h dash obvious है negative होगा. ठीक है, तो h dash negative है, h positive है, तो m has to be negative. And if both are positive, means image formed is virtual, then m is positive. Similarly, if we take modulus of m, we'll consider the number also. Okay, if modulus of m is greater than 1, then image is magnified. If it is less than 1, then image is reduced. And if magnification is equal to 1, then image is of same size as the object. Okay? So what is the mirror formula? ये basic है, just one slide.
1 by v plus 1 by u is 1 by f.
What is the formula for magnification for mirrors?
M is equals to minus V by is equals to H dash by H.
What is the nature of the image formed if the magnification is positive?
Virtual and erect.
Ishangi, do you know the answers? Bhavesh, Ishangi?
Yes, ma'am.
So you should also respond, right? Give an example of mirror whose magnification is 0.5.
मैम ये 1 से कम है ना, तो रियल एंड इन्वर्टेड देगा.
See,
0.
nothing is written means it is positive, no?
हाँ.
So what kind of mirror is this?
वर्चुअल शायद से पॉजिटिव है फिर.
What kind of mirror is this? It's a very simple question.
Convex.
It's convex mirror. In convex mirror, virtual and smaller images are formed, right? Smaller and therefore it is less than 1, and virtual therefore it is positive. Okay. The magnification for a mirror is -3. How are U and V related? It's very easy question. फटाफट बताओ.
B is equals to, मैम B is equals to 3U.
For which position of the object magnification of a concave mirror is -1?
रियल एंड इन्वर्टेड है ना मैम. मैम C पे.
At center of curvature. According to sign convention, the radius of curvature of a convex mirror is taken as positive or negative.
पॉजिटिव मैम.
Bhavesh, Ishangi, please respond. Arshia, you also know the answer, right? If M is greater than 1, is the image formed enlarged or reduced? Yes, Shriram? If M is greater than 1, is the image formed enlarged or reduced?
मैम enlarged होनी.
If M is less than 0, is the image formed erect or inverted? Very basic question again.
Inverted होना चाहिए.
Whether the value of magnification of rear view mirror used in cars is positive or negative?
Positive.
An object is placed at a distance of 2f from the concave mirror of focal length f. The magnification of the image is?
Same मैम. Plus -1 only.
It's -1. Okay, now we have a question. The direction of ray of light incident on a concave mirror is shown by PQ, while directions in which the ray would travel after reflection is shown by 4 rays marked 1, 2. Look at these rays 1, 2, 3, and 4. Which of the 4 rays correctly shows the direction of reflected ray? Mayank, please turn on your camera.
मैम मेरे हिसाब से 2 होना चाहिए.
नेटवर्क इशू आ रहा.
Sorry, beta, what did you say, Ram?
मैम मैं ये कह रहा हूँ कि इस क्वेश्चन में 2 होना चाहिए आंसर, क्योंकि हमें ये पता है कि जब भी कोई लाइट फोकस से कॉन्केव पे टकराती है तो वो प्रिंसिपल एक्सिस के पैरेलल होती है.
Yes. Okay, what do you think, Ishangi?
Ma'am, 2 only.
2 hoga, because this is the incident ray and this ray is passing through the focus. We can see. This ray is passing through the focus, so it will become parallel to the principal axis after reflection from the mirror. So this is the correct answer. Okay. Yes, please read this question. You have learned that plane and convex mirrors produce virtual images of the objects. Can they produce real images under some circumstances? Explain. कैसे करोगे?
मैम
Yes, please.
अगर ऑब्जेक्ट वर्चुअल है तो उससे होगा कुछ.
अगर object virtual है तो we can get a real image. And how will you get the virtual object? How will you get the virtual object?
पैरेलल मिरर से.
First, draw these 3 plane mirrors. Now draw the principal axis. So if we have an object placed in front of the mirror, if the object is placed in front of the mirror, so we can draw incident rays, right?
Okay, ma'am.
Like this. So these are the incident rays which can be drawn. And if we have an object which is at infinity, then we can draw incident rays like this. See, we can also get incident rays in this way. So you can see that these rays are converging, right? This is first case where the object is placed in front of the mirror, close to the mirror. And this is the second case where the object is placed at infinity, then we get parallel rays. And this is the case, I don't know from where, we don't know, but we are getting these converging rays which are falling on the mirror. Okay. So in the first case where we have incident rays like this, see, object is placed very close to the mirror. So we'll have incident rays like this. We can draw normal here. है ना? So normal draw कर लिया. This is your angle of incidence. This angle is your angle of incidence. We can draw reflected rays. How do we draw reflected rays? We draw reflected rays like this. So these are the reflected rays. And this arrow shows the direction of reflected ray. And if these, you can see these rays are diverging, they will never meet in front of the mirror.
Never meet.
So we
और मैम तो फिर वर्चुअली मीट कराएंगे, फिर जो आएगा ना उस ऑब्जेक्ट से दूसरे वाले को, और सिमिलरली उससे जो इमेज बनेगी ऑब्जेक्ट की, उससे तीसरे वाले से हम मिलके वर्चुअल ऑब्जेक्ट ऐसे करके इमेज बना.
एक बार सुन. ठीक है. So these rays will never meet in front of the mirror. So we extend them in backward direction. The point where they meet is the position of image. So in this way, our object is a real object. We have a real object and we are getting a virtual image behind the mirror. Okay, clear? Now, what if we have object at infinity? Then what? If we have object at infinity, then?
मैम फिर उससे कन्वर्ट.
Rays will reflect back along the same path. So we'll get again image at infinity. Okay, so here we have parallel rays, we have real object. So we have real object and virtual image. Okay, now consider this case where we have converging rays coming towards the plane mirror. Now, what will we do now? Yes, anyone? Can you please respond? Bhavesh, do you know the answer? Ishangi, Lavanya, Arshay? If the rays are converging and they are falling on the mirror, तो हम क्या assume कर सकते हैं कि कोई ऑब्जेक्ट है जहां से ये रेज आ रही हैं. ठीक है ना? We can extend these rays in backward direction like this. अब क्या करोगे? So the point where the two rays meet is the position of virtual object. So we are assuming that we have a virtual object behind the mirror. We have a virtual object behind the mirror. Okay, you can see these rays. These are coming towards the object. We can draw a normal like this. Okay, so this is the angle of incidence. Now we can draw reflected rays. The point where the reflected rays meet is the position of your real image. Because rays are actually meeting at this point, right? है ना, rays are actually meeting at this point. देखो, अगर rays converging rays हैं और वो mirror पे strike कर रही हैं, अगर rays converging है and they are striking at the mirror, so we can apply laws of reflection like this. Rays will reflect and they'll meet at a point in front of the mirror. So if the rays are actually meeting at a point in front of the mirror, then the image will be real image. See, you know the difference between real and virtual image, right? In case of virtual, what do we say? For virtual image, we say that reflected rays appear to meet. Apparent intersection of rays, right? This is what we say. This is what we write for virtual image. Appear to meet, apparent intersection of image. While for real image, how do we write? For real image, we say that the image are actually meeting at a point.
Yes, ma'am.
इसमें क्या होता है? Appear to meet होता है. इसमें actually meet होता है. they actual में meet करती है रेज. तो यहाँ पे रेज एक्चुअल में मीट कर रही है, वी कैन सी, है ना, यहाँ पे रेज एक्चुअल में मीट कर रही है, इसलिए कौन सी इमेज फॉर्म होगी? रियल इमेज.
एक बार हम खुद से कर ले क्या, जो केस आपने बताया था?
हाँ करो
प्लेन
तक तो हो जाना चाहिए था. प्लेन मिरर का दोबारा करना है आपने?
प्लेन मिरर वाले में जैसे आपने बताया था वैसे हम ये भी प्रूफ किसके थ्रू ये भी प्रूफ कर सकते हैं कि
करो. See, in the first case, let's consider two rays which are converging. अब ये जो rays are, look at these two rays, they are incident on this mirror in the direction of focus. How do you draw the ray diagram when we have rays which are incident, you know, in the direction of focus? We draw the rays parallel to the mirror. Sorry, parallel to the principal axis. Second case is if the rays are parallel and they are incident on convex mirror. Rays are parallel and incident on convex mirror. Then after reflection, they appear to diverge in the direction of focus. And we say that the image is formed at F. See, in this case, we get a virtual image, right? But if we have diverging rays, थर्ड केस, देखो यहाँ पे हमने जो रेज ली थी फर्स्ट केस में, वो कैसी रेज थी? वो रेज थी जो कन्वर्ज हो रही थी. You can see incident rays are converging. And here we have incident rays which are parallel. So we can draw normal like this. It passes through the center of curvature. This is the normal and it passes through the center of curvature. So this angle is angle of incidence and this angle is also angle of incidence. Now we can draw angle of reflection now. This is the angle of reflection. In this case, rays are meeting in front of the mirror. These are the reflected rays and they are meeting in front of the mirror and this is the position of the image. So this is the real image we are getting. Again, you can see the rays are actually meeting at this point. So this image is real image. Okay. Where is the
मैम फर्स्ट और ये सेम नहीं है? फर्स्ट और ये सेम नहीं है?
नहीं नहीं बेटा,
फर्स्ट वाला डायग्राम।
नहीं नहीं नहीं, फर्स्ट वाले डायग्राम में हम उसको पैरेलल पास करवा रहे हैं ना, यहाँ पे हम पॉइंट ऑब्जेक्ट के जैसे कंसिडर कर रहे हैं। यहाँ देखो, फर्स्ट वाले केस में जो रेज इंसिडेंट हो रही हैं वो फोकस की डायरेक्शन में इंसिडेंट हो रही है। ये जो रेज इंसिडेंट हो रही हैं ये फोकस की डायरेक्शन में इंसिडेंट नहीं हो रही है, ये कहीं और हो रही है। क्लियर है अर्षद?
यस मैम।
अगर आपकी रेज फोकस की डायरेक्शन में इंसिडेंट होती हैं तो वो प्रिंसिपल एक्सिस के पैरेलल होती है। लेकिन अगर आपकी रेज फोकस की डायरेक्शन में इंसिडेंट नहीं हो रही है, किसी और डायरेक्शन में इंसिडेंट हो रही है, तो वो पैरेलल नहीं होंगी ना प्रिंसिपल एक्सिस के। ठीक है? So this is the real image, because real image always forms where the rays actually meet at a point, and this position is the position of virtual object. So we say that there is a virtual object which is placed behind the mirror, and we are getting the real image of that virtual object which is placed behind the mirror. Okay, this is how you have to do this question. Clear? A small candle 2.5 centimeter in size is placed at 27 centimeter in front of a concave mirror of radius of curvature 36 centimeter. So we have a concave mirror. In concave mirror, we take U negative, F is negative, focal length is negative. Height of the object we always take positive, right? So we have a small candle 2.5 centimeter in size. So height of the object is given 2.5 centimeter. It is placed at 27 centimeter in front of a concave mirror. Object distance is given, it is minus 27 centimeter.
May I go to washroom, please?
Please, please, please. And radius of curvature is given, it is minus 36 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? We have to find V. Describe the nature and size of the image. Nature means we have to find magnification, and for size we will find height of the image. Okay. Now we have, if the candle is moved closer to the mirror, how would the screen have to be moved? This we'll discuss later after doing this. Okay, so this is focus, this is center of curvature. So radius of curvature is given, it is 36 centimeter. And object distance is minus 27. So focal length क्या होगा? अगर radius of curvature minus 36 centimeter है, so focal length, how are they related? Focal length is half of radius of curvature. So it is minus 36 upon 2 minus 18 centimeter. Okay. So what does it mean? It means that object lies between focus and center of curvature. Now we have got a basic idea कि हमें एक estimate पता लग गया कि हमारा जो object है, it lies between focus and center of curvature in front of the concave mirror. So this is 18 centimeter. ठीक है, और ये आपका कितना है? 27 centimeter. It lies between these two. तो यहाँ से आपको एक estimate मिल जाता है, एक basic सा एक rough idea मिल जाता है. वो rough idea क्या है? वो rough idea ये है, because our image is object is between focus and center of curvature, तो image कहाँ बनेगी? Beyond C. ठीक है, तो आंसर शुड बी ग्रेटर देन 36 सेंटीमीटर इन नेगेटिव. एंड सेकेंड, इमेज फॉर्म्ड इज रियल एंड इन्वर्टेड, so m has to be negative. Second, because when we have object between focus and center of curvature, then image is enlarged and behind the, beyond C and enlarged. So m is negative and mod m should be greater than 1. ठीक है, और क्या बेसिक आइडिया मिलता है हमें कि हमारा जो h डैश होगा वो आपका नेगेटिव होगा, और मॉड h डैश जो होगा आपका वो ग्रेटर देन 2.5 सेंटीमीटर होगा. तो ये आपको एक एस्टिमेट, एक रफ आइडिया हो गया यहाँ से. ठीक है, सो ऑलवेज ड्रॉ अ रफ डायग्राम लाइक दिस, बिकॉज उससे आपको कुछ एस्टिमेट लगा सकते हो कि हाँ आपका आंसर करेक्ट साइड में जा रहे हो या रॉन्ग करा कुछ आप. नाउ विल यूज मिरर फॉर्मूला हियर, एंड इट इज 1 upon v plus 1 upon u is equal to 1 upon f. Now put the values. This implies 1 upon v plus 1 upon u is minus 27. F is minus 18. So we can write 1 upon V as minus 1 by 18 plus 1 by 27. Okay, now we can solve this. LCM is 54 and in the numerator we get minus 3 plus 2. This is minus 1 by 54. On comparing these two, take the reciprocal, you'll get V as minus 54 centimeter. So we can say that image is formed at a distance of 54 centimeter in front of the mirror. You have to write this here. Okay, statement at the end. Now we have to find nature and size of the image. For nature and size of the image, we'll find M first and then H dash. So M is equal to H dash minus V by U, we can write. Okay, V is minus 54, so we can write minus of minus 54 divided by U is minus 27. So what is M?
Nature real and inverted.
Minus 2 आ गया. So image magnification is negative, therefore image is real. And mod M is greater than 2, greater than 1, sorry. Mod M is greater than 1, therefore image is enlarged. Now we'll find the size of image. Size of image is H dash. H dash is equal to M into H. M is minus 2, H is 2.5. Therefore your H dash is plus 2.5 now. H dash is minus 5 centimeter. Again, H dash is negative, therefore image is real. And this is the size of image, 5 centimeter. Now in the second half of the question, we have if the candle is moved to closer to the mirror, how would the screen have to be moved? See, if we have how we move the screen if the candle is moved closer to the mirror. If we move a candle at this position at focus, then image is formed at infinity. है ना? देखो अगर आप cases ले लेते हैं, let's consider different cases. So if we have image, if we have an object beyond C, image is formed between F and C. Now let's move our object towards the mirror. So if we move our object towards the mirror at C, then image is formed at C. So we can see that screen is moving away from the mirror. If we move our object towards the mirror, then image screen has to be moved away from the mirror. बस F तक, up to F. Because इसके बाद जब आप ऑब्जेक्ट को पास लेके जाओगे तो आपको इमेज मिरर में दिख जाएगी because you get virtual image, it is formed behind the mirror. But up to F, अगर आप ऑब्जेक्ट को मूव करोगे towards the mirror, then screen has to be moved away from the mirror. देखो बियॉन्ड सी का बिटवीन एफ एंड सी बन रहा है. ऑब्जेक्ट को आगे लेके आए एट सी पे तो इमेज यहां से पीछे आ गई. अब ऑब्जेक्ट को और आगे लेकर आए बिटवीन एफ एंड सी पे तो इमेज और पीछे चली गई. ऑब्जेक्ट को और आगे लेके आए एट एफ पे तो इमेज इंफिनिटी पे बन. प्लीज रीड द क्वेश्चन एंड ट्राई टू डू दिस. आपका बेटा वो एनसीईआरटी पे बेस्ड है ना, उसमें सारे एनसीईआरटी के क्वेश्चंस होंगे और जो मैं करवा रही हूँ वो भी एनसीईआरटी और एग्जाम्पल. ठीक है. यस, कैसे करेंगे? वी हैव अ कॉन्वेक्स मिरर. स्नेहा, प्रिपरेशन हो गई एग्जाम की?
यस मैम, हो गई, थोड़ी सी बची है बस.
So we have a convex mirror. Draw a convex mirror first and the principal axis. A 4.5 centimeter needle is placed 12 centimeter away from a convex mirror. So we have a needle and length of the height of the needle is given. It's 4.5 centimeter. H is 4.5 centimeter. And it is placed 12 centimeter away from a convex mirror. See, we'll take U as negative because it is against the direction of incident ray, right? So we take U as negative minus 12 centimeter and focal length is given. Focus is here behind the mirror. So we'll take focal length as positive. So focal length is plus 15 centimeter. Now question is, give the location of the image and the magnification. We have to find the location of the image. Location of the image means V, image distance, and magnification. Magnification is small m. Okay, so these two quantities we have to find out. So describe what happens as the needle is moved farther from the mirror. We'll discuss this. We'll take this later. So as we know, mirror formula is 1 upon V plus 1 upon U is equal to 1 upon F. So we can apply the values here. Okay, so 1 upon V we don't know. The value of U is given, it's minus 12 and F is 15. Okay, so this implies 1 upon V is equal to 1 upon 15 plus
20/3 आ रहा है आंसर.
हाँ जी क्या आ रहा है बेटा?
20/3.
Okay, let's see. LCM is 60. Okay, 15 fours are 60, 4 ones are 4 plus 12 fives are 60, 5 ones are 5. So it's 9/60, or we can take the reciprocal again. So V is plus 60/9, or in decimal it's plus 6.7. Are you getting this? Plus 6.7 centimeter? No? Yes, Ram?
Yes, मैम वो फ्रैक्शन में कर देंगे ना, फिर उसको 20/63 आ रहा है मेरा.
Okay. See, because V is positive, what does it mean? It indicates
Virtual image.
image is found behind the mirror. And its value is given, it is 6.7 centimeter. So at a distance of 6.7 centimeter from the mirror, right? And in mirrors, if we get virtual image, it is always found behind the mirror. So image is virtual, but we need to prove it. How will we prove it? For this, we'll find magnification first. Because magnification is h dash by h, where h dash is the size of image divided by size of object is equal to minus v by u. Now put the values here. This implies h dash, h is given, it is 4.5. V is, we have just found out, it's 60/9. And U is given, it's minus 12. Minus minus cancel, 12 ones are 12, 12 fives are 60. Okay, it's 5/9. So we can find the value of h dash. So h dash is 5/9 into 4.5. Anji, please tell me the answer.
5 आ जाएगा मैम.
Plus 2.5 centimeter. So we can see that h dash is positive. It means that the image is virtual and erect, and it is smaller than the object. The value, height of the image is 2.5 centimeter and that of object was 4.5. It was given, yes, so it is smaller, virtual and smaller. Please write this. Now we have second half of the question. In this, it is asked that what happens as the needle is moved farther from the mirror. If you move the needle away from the mirror, then what happens?
And image will be formed at the focus, right? Because अगर हम इनसे दूर कर देंगे तो फोकस पे तो बनेगी ना इमेज. पहले वाला केस की बात कर रहे हैं.
हाँ, but F पे बनेगी, but up to F. And size of the image goes on decreasing. है ना?
Yes, क्योंकि ये रिजल्ट हमेशा होता है कि जब भी इंफिनिटी पे होता है ना ऑब्जेक्ट, तो फोकस पे बनते हैं लेकिन बड़ी पॉइंट साइज इमेज बनती है.
हाँ,
चाहे फिर वो कॉन्वेक्स मिरर हो या कॉनकेव मिरर.
हाँ, image goes on decreasing in size. Up to F, है ना? Up to F we can do. See, use the mirror equation to deduce that. Use the mirror equation to deduce that, number 1, an object placed between F and 2F of a concave mirror produces a real image beyond 2F. B part is a convex mirror always produces a virtual image independent of the location of the object. C is the virtual image produced by convex mirror is always diminished in size and is located between the focus and the pole. And D part is an object placed between pole and focus of a concave mirror produces a virtual and enlarged image. So we have 4 parts in the same question. Yes. राम को तो पता है, बाकी किसी और को आइडिया है कैसे करना है?
मैम आपने क्लास में करवाया था
I think first part we had covered in the class, just one part, first part. Not all the parts have, were covered. Yes, Ram. Arshya, बताओ.
सबसे पहले तो डायग्राम बनाएंगे फोकस और फिर सेंटर ऑफ कर्वेचर आ जाएगा.
Yes.
अब हमें मैम ये दे रखा है कि ऑब्जेक्ट जो है वो F और 2F के बीच में प्लेस है. तो हम क्या मानेंगे कि अगर दोनों डिस्टेंस F होगी, क्योंकि हमें ये पता है फोकस जो है वो पोल और C का मिड पॉइंट होता है. अब अगर ये दोनों F है तो जो X, अगर X को हम वो मान के चलने कि ये सेंटर ऑफ कर्वेचर से और फोकस के बीच में थोड़ा सा पहले है, तो वो हमेशा उसकी डिस्टेंस F से हमेशा कम होगी.
Yes.
तो हम मान सकते हैं F माइनस X.
ठीक है. देखो अब इसमें क्या करना है, आप ध्यान से सुनना. ठीक है. We have an object placed between F and 2F. 2F is center of curvature. And we have to prove that if we place an object between focus and center of curvature, then image is always formed beyond 2F. A real image is always formed beyond 2F. We always get image here. Okay?
Yes,
this is what we have to prove. Now we have to prove this mathematically. Okay? How are we going to prove it? See.
हम पहले तो मिरर फॉर्मूला लगाएंगे 1/v plus 1/u is 1/f.
तो देखो इसमें करना कैसे है कि from pole to focus we can take focal length as, we denote focal length as small f, and we know that PF and FC are equal, right? So if PF is small f, then FC is also small f. And now we have placed an object between F and 2F, between focus and center of curvature. So we can say that this object is at a distance x from focus. So in this way, we can write the object distance. Object distance is denoted, and because you can see that it is on the negative side, or we can say that it is against the direction of incident ray. U is measured against the direction of incident ray. So we'll take U as negative. So U is minus C, PF plus this distance. PF is small f, and this distance is x. So we'll take small f plus x. In case of concave mirror, focal length is negative. So we'll write minus f of focal length. We can easily find V, okay, using the mirror formula. So we can write as 1/v plus 1/u is equal to 1/f. Okay, now put the values here. 1/v plus 1 upon minus f plus x for u is equal to 1/minus f for focal length, because we consider sines also. So this implies 1/v is equal to minus 1/f. Now move this to the other side, it will become positive upon 1 upon f plus x. Now take the LCM, you will get 1/v is equal to f plus x is the LCM. So f common, we have f plus x, which is not here. So we'll write f plus x here with a negative sign, plus f plus x दोनों में है, f नहीं है, तो f को 1 से मल्टीप्लाई करोगे तो f आ जाएगा. So this implies 1/v is equal to minus f minus x plus f. F cancel हो जाएगा, you'll get minus x in the numerator, f upon f plus x. Now because it is 1 upon v, so we can write v as, by taking reciprocal, we can write v. Okay, so v is f minus f into f plus x divided by x, or we can write this as minus f in the bracket, we'll write f by x plus 1. Now देखो अब यहाँ पे क्या है, ये आपका fc जो है this FC is F. And अगर इसको हम कुछ assume करते हैं, let the object be AB. So FB is smaller than FC. It is seen clearly. We can see that FB is smaller than FC. What is FB? ये distance है ना, ऑब्जेक्ट का डिस्टेंस है पोल से F plus X. तो FB क्या है? X है, right? तो X is less than FC is F, small f. X is less than F. तो आपका जो न्यूमरेटर है, because X is less than F, therefore F by X is greater than 1. So you are getting this fraction greater than 1. So this number would be greater than 2. है ना? This implies F by
तो ये
X.
1 में कुछ भी जोड़ो तो 2 से बड़ा ही है.
हाँ, F by X is greater than 1 and therefore F by X plus 1 is greater than 2. Okay, so this is greater than 2, so we can write V as greater than 2F. With a negative sign. Negative sign indicates that image will be formed where the object is. Okay, in front of the mirror. We have a negative sign here. So this negative sign is for the location of image. It is in front of the mirror. Therefore, we have a negative sign. It is greater than 2F. Please write this. See, now we have second part of the question. In the second part, we are given a convex mirror. Okay, so please draw a convex mirror first. Draw the principal axis. So we have a convex mirror. We have to prove that it always produces a virtual image. So if you place an object in front of the convex mirror, then we always get a virtual image behind the mirror. And this virtual image is independent of the location of the object. Okay, it does not depend upon the location of the object. It is independent of the location of the object, and this we have to prove. Okay, because we have a convex mirror and we know that convex mirrors have wider field of view, and we always get virtual and smaller image in convex mirror. Image is always formed behind the mirror and it is smaller. This is, you know, ये हमें पता है. We have been studying this from lower classes. Okay, so it's very common, very simple topic. We know that because in case of convex mirror, focal length is positive, right? So F is greater than 0 and U is less than 0. If you use the sign convention, because object is placed on this side of the mirror, so it is negative. Let X be the distance of the object from the mirror and small f is the focal length is equal to 1 by F. So from here we can write 1 by V as 1 by F minus 1 by U. Now because our F is always greater than 0 and U is always less than 0. Because U is less than 0, so this become positive. So we'll get a positive number from here. So this positive now, positive ही आएगा ना, U negative है और F positive है तो minus minus plus हो जाएगा, right? तो एक positive number है यहाँ से. This positive number indicates that image is formed behind the mirror. Second method is, you please listen to me very carefully, children. ठीक है? अब क्या है? Second, आप क्या कर रहे हो? ये तो बहुत easy, convenient, ठीक है? Mathematics को हम ऐसे prove कर सकते हैं. Second way क्या है? You just write U as minus X. Okay, because object is placed at a distance of X from the mirror and F is positive. So we'll take F as positive. Now use the mirror formula. It's 1 upon V plus 1 upon U is equal to 1 upon F. So this implies 1 upon V is equal to 1 upon F minus 1 by U. Now put the values here. It's 1 by F minus X. U is minus X. So we can write minus X for this. Minus minus becomes plus. So 1 by F plus 1 by X. Okay, or we can get 1 by V is equal to, we'll take the LCM, it's XF. In the numerator, we'll have F plus X. So this implies V is XF upon F plus X. Okay, now we can find magnification. Because we know that magnification of a mirror is minus V by U. Okay, so put the values here. V is XF upon F plus X and U is minus X. Okay, so on simplifying we get F upon F plus X. which is positive. Okay, so we can see that M is positive, therefore image formed is virtual. And second,
Yes.
we can find that because we have something in the denominator which is greater. So we can see that F magnification is less than 1 and therefore image formed is smaller.
ओके मैम.
ये आप बोल रहे थे है ना राम?
हाँ मैम, ये मेरा मेथड था.
हाँ, तो वो ऐसे ओरली समझ नहीं आता ना बच्चों को, तभी मैंने फिर लिख कर बता दिया. बाकी इसको आप ऐसे भी अगर करके आओगे, यहाँ पे छोड़ के भी आओगे, तब भी कोई रॉन्ग नहीं कर सकता, क्योंकि आपका कॉन्सेप्ट क्लियर होना चाहिए, पता होना चाहिए कि हाँ आपने जो किया है वो ठीक है. In the third part, we are given a convex mirror. We have to prove that in a convex mirror, a virtual image is always diminished in size and is located between the focus and the pole. Similar question, no? We have a convex mirror. Image is placed in front of the mirror and object is placed in front of the mirror and image is formed behind the mirror in this case. So we have to prove that image is diminished and it is always between pole and focus. कैसे प्रूव करोगे बताओ? See, because we know the mirror formula, it's 1 upon V plus 1 upon U is equal to 1 upon F. So this implies 1 upon V is equal to 1 upon F minus 1 upon U, right? So we are subtracting something from this to get this. Anna? So what does it mean? It indicates that 1 upon V is greater than 1 upon F. Because we are subtracting 1 upon U from 1 upon F to get 1 upon V. So this implies 1 upon V is greater than 1 upon F, right? Or we can say, if we take the reciprocal, then we change the sign. This implies V is less than focal length. So image distance is always less than focal length, means image is formed between pole and focus. Write this. So it indicates that image is formed between pole and focus. And second way of doing this question is that because in the previous section we had done that V is equal to XF upon X plus F. So this thing is less than F, therefore image lies between P and F. And second, magnification is F upon X plus F and it is less than 1. Therefore image is always diminished. We can do this question like this. Okay, so there are two ways of doing it. Should I clear the screen? An object placed between the pole and focus of a concave mirror. Now we have a concave mirror. An object is placed between pole and focus. So when we place the object very close to the concave mirror, then where is the image formed?
Ma'am, behind the
image will be formed behind the mirror. Virtual and last. Yes. So we have to prove this, that if we place the object between pole and focus, then image is formed behind the mirror. Image formed is virtual and highly enlarged. See, because we have a concave mirror, so F is negative. We can take the object distance as X, small x. So U is also minus X. So we can find V. Okay. So we will use the same formula, mirror formula here. 1 upon V plus 1 upon U is equal to 1 upon F. Put the values here, 1 upon v plus 1 by u. For u, we'll write minus x is equal to 1 upon minus f. So this implies 1 upon v is equal to minus 1 by f plus 1 by x. Or we can take the LCM. In the denominator, we'll have fx. It is f minus x in the numerator. So this implies v, take the reciprocal, is equal to xf upon f minus x. Okay? Now we know that x is less than f. This is f, distance between pole and focus. An object is placed between pole and focus, right? Somewhere here. So x is less than f. Now because x is less than f, so this number is positive. F minus x is positive. Right? F minus x is positive. And we have, see, numerator and denominator both are positive. This implies v is positive. So image will be formed behind the mirror. Because if we are getting v as positive, it is clear that image is formed behind the mirror. Okay. And what about magnification? Magnification is minus v by u. Now put the values. It's v is this. So we can write xf upon f minus x and u is minus x. Negative negative cancel हो जाएगा और x से x cancel हो जाएगा तो ये आपका आ जाएगा f upon f minus x. So we can see because x is less than f. So we have see because x is less than f, therefore denominator is positive, indicates m is m positive. Because m is positive, therefore image formed is virtual. And second thing is, you can see that f is greater than f minus x. So our numerator is greater than denominator, right? Because numerator is greater than denominator and therefore m is greater than 1. Therefore, because m is greater than 1 and magnification, if magnification is greater than 1, it indicates that image is enlarged. Okay, so image is virtual and enlarged. Positive hai v isliye behind the mirror, so we got all these three: virtual, enlarged, behind the mirror. ठीक है? There is one more way of doing this. कैसे करोगे? आपका जो focal length है, focal length is greater than x, है ना? No, but if we compare this as according to sign, if we take a negative, then negative of f, if we take negative sign also, if we consider negative signs, then we can write f as less than u. Can we write like this? More negative is smaller, na? F is more negative than x. F is more negative than x, so therefore it is smaller, and u is less than 0. So therefore 1 upon f minus 1 upon u is greater than 0. So this implies 1 upon v is greater than 0 or v is positive. We can do this question like this also. Okay, easy and simple. देखो, we have a short object of length L. So L is the length of the object. Okay, we have a short object of length L. It is placed along the principal axis of a concave mirror away from focus. The object distance is u. So we can take the object distance from the center of the object. From here we can take it's u. And focal length is small f. If the mirror has a focal length f, what will be the length of the image? We have to find L dash. What will be the length of the image? Okay, this is what we have to do. Usually we have, point objects and we find point images, right? वो easy होते हैं. But here we have an object जिसकी considerable length है. उस केस में हम क्या करेंगे? See, we can write let the two ends of the object be at distances u1 is equal to, देखो सेंटर से हम u ले रहे हैं, राइट? टू एंड्स आर these are the ends. तो ये वाला जो डिस्टेंस है, लेट दिस डिस्टेंस बी u1, मतलब फ्रॉम यहां से वन एंड से पोल तक का डिस्टेंस इज u1 and distance between pole and other end of the object be u2. So we can write u1 as u minus l by 2. Any doubt? See, because this is l now, so we can write this as l by 2, l by 2. So u1, this is u1. u1 क्या है? जो नियर वाला एंड है, नियर एंड से पोल का डिस्टेंस इज u1. u1 u में से l by 2, दिस इज u फ्रॉम द सेंटर. So u में से l by 2 को माइनस करोगे तो u1 आ जाएगा. Similarly, we can write u2. What should I write? What should I write for u2? U is this distance till here, till the center is u, and then we have l by 2 extra. So we can write u plus l by 2. I hope this is clear. जैसे ये ऑब्जेक्ट है, यहां से डिस्टेंस इसका u1 है, ठीक है? This distance is u2 and from the center it is u. Okay? तो ये आपका l by 2 है. तो u minus l by 2 is u1 and u plus l by 2 is u2. We have done this. Okay? यही किया है हमने. I hope इसमें कोई डाउट नहीं है. Clear है? You can give me a thumbs up if it is clear. See, so we can write size of the object. Size of the object is L, it is given. We can write this as modulus u1 minus u2. ठीक है? जो भी वैल्यू आएगी उसको हम पॉजिटिव लेंगे, मॉड में कर दिया हमने. Basically we are going to find this difference, right? u1 minus u2 आपका L हो जाएगा. Similarly, for the image, we can write size of the image is denoted by L dash and it is v1 minus v2. ठीक है? As 1 by v plus 1 by u is equal to 1 by f. Now use this identity to find v. ठीक है? So this implies 1 by v is equal to 1 by f minus 1 by u. So it is u minus f by fu. This is how we can write, है ना? और इसको अगर आप रेसिप्रोकल लेते हो तो you get v as fu upon u minus f. This is your v. fu upon u minus f. ठीक है? Now we can find v1 and v2. ठीक है? Because v is fu upon u minus f, so we can write v1 as f u1 upon u1 minus f and v2 as f u2 upon u2 minus f. ठीक है? Now you can find the size of image. Size of image is L dash. ठीक है? L dash. So first write v1 and then v2. ठीक है? For v1 I'm going to write f, and for u1 is u minus l by 2. So wherever I have u1 I'll write u minus l by 2. Okay, u minus l by 2. In the denominator again we have u1, so we'll write u minus l by 2 minus f. Okay, so this is your v1 and v2 is this fu2 upon u2 minus f, so minus v2. f u2 is u plus l by 2. u2 is given, it is u plus l by 2. In the denominator again we'll write for u to u plus L by 2 minus f. Okay? Clear? Now we can see that in the denominator we have these two terms u minus f, है ना? So we can write them in bracket and plus L by 2 minus L by 2 अलग अलग हम लिख सकते हैं. No? है ना? We can write u minus f in one bracket and minus L by 2 here, and here we can write u minus f together and plus L by 2. It's like a minus b, a plus b. So when you'll take the LCM for solving this, in the denominator you will get a square minus b square. ठीक है? क्या आएगा? a square minus b square. ठीक है? So we can write this as u minus f whole square minus L by 2 whole square. Okay? a minus b a plus b है. अब इसको न्यूमरेटर को जब सॉल्व करोगे, पहले तो सॉल्व करो और मुझे बताओ क्या आ रहा है सिंप्लीफाई कर. Solve this and tell me. For L by 2 whole square, we can also write L square by 4. See, after 8 minutes meeting will end. So मुझे थोड़ी सी बात भी करनी है आप लोगों से. तो ये हम कंप्लीट कर लेते हैं फटाफट. I'm writing the answer. You can do it. Okay? You just have to multiply and expand. Cancel the terms जो cancel होती हैं. उसके बाद you will get in the numerator f square L. This is what you will get in the numerator, and the denominator we have this. Because our object is quite short, as the object is short and kept away from the focus, therefore L square by 4 is very, very small. You know, it is very small than this. You can neglect this u minus f whole square. So this can be written as, it is nearly equal to f square L upon u minus f whole square. This can be neglected because this is very small. Okay? So this is the final answer you'll get. This is the length of the, or we can say size of the image. Okay? Size of the image is this. Please write this.